Welcome to the DIY Honda Garage channel. The Diagnostic Trouble Code, DTC P0328, indicates a high voltage condition in the knock sensor circuit. The knock sensor plays a critical role in the engine management system by detecting engine knocking or pinging, which can indicate improper fuel combustion. It is typically located on the engine block, close to the combustion chamber, allowing it to accurately monitor vibrations. The Engine Control Module, ECM, also referred to as the Powertrain Control Module, PCM, in Honda terminology, uses input from the knock sensor to adjust ignition timing and fuel delivery for optimal engine performance. A signal from the knock sensor that is too high can lead to engine performance issues, poor fuel economy, and potential engine damage. Understanding this DTC and its implications is crucial for maintaining the performance and longevity of the vehicle. The knock sensor's primary role is to detect unwanted knocking in the engine, which can lead to reduced performance and potential damage if not addressed. Located typically on the engine block, the knock sensor is designed to respond to specific vibrations created by knock events. The PCM receives these signals and alters the ignition timing to prevent detonation, ensuring that the engine runs smoothly. High voltage readings signify an issue with either the sensor or the circuitry connected to it. This could lead to engine struggles such as misfiring and inefficient fuel usage. Pinpointing the exact problem within the knock sensor circuit is essential for effective diagnoses and repairs. There are several possible causes that might trigger DTC P0328. A faulty knock sensor itself is one likely culprit. It may be providing erroneous high voltage readings due to internal failure. Additionally, wiring issues such as frayed or shorted wires can cause the electrical signals to fluctuate, leading to inaccurate voltage readings. It's also possible that the PCM, which processes signals from the knock sensor, might be malfunctioning or outdated. Always consider these possibilities when troubleshooting the DTC to ensure accurate diagnoses and repairs. A systematic approach can help isolate the specific area of failure within the system. Symptoms associated with DTC P0328 can vary, but typically include noticeable reductions in engine performance. Drivers may experience poor acceleration or unstable engine behavior, indicating that the PCM is unable to adjust ignition timing correctly. This DTC can also lead to decreased fuel economy due to inefficient fuel combustion resulting from incorrect timing. Another key indicator is engine misfires, which can create odd noises and vibrations that are often felt during acceleration. Recognizing these symptoms early can prevent more serious engine damage and costly repairs. Addressing these issues promptly is essential for vehicle longevity and performance. The first step in troubleshooting DTC P0328 involves verifying the current status of the vehicle's diagnostic system. Start by turning the vehicle to the on mode without starting the engine. Following this, use the Honda Diagnostic System, HDS, to clear any existing DTCs. This step is crucial at this stage to ensure that you are working with the most current diagnostic data. After clearing the codes, turn the vehicle to the off or lock position. Then, return to on mode again and check for any pending or confirmed DTCs. If DTC P0328 is confirmed, it indicates a persistent issue that needs to be addressed, whereas transient failures may show no DTCs at this time, possibly necessitating inspection for poor connections. In this step, you will need to pinpoint the failure area related to the knock sensor. Begin by ensuring the vehicle is in the off or lock mode. Disconnect the knock sensor 2P connector, which connects the sensor to the PCM. After disconnection, Turn the vehicle to the on mode to prepare for voltage measurements. Using a multimeter, measure the voltage between test points 1 and 2 on the knock sensor 2P connector. Test point 1 is on terminal 1, and test point 2 is on terminal 2 of the connector. The expected voltage should be around 5.0 V. If this value is detected, it indicates that the wiring and the sensor's electrical connection are operational, suggesting that the issue lies within the sensor itself and replacement is warranted. Next, you will check for potential issues with the knock line and KSGND line. With the knock sensor still disconnected, measure the voltage again. This time between test point 2 of the knock sensor 2P connector and the body ground. Turn the vehicle to the on mode for this check. The voltage reading should ideally show about 5.0 V. If this level is present, it indicates that the KSGND line is functioning correctly. Once confirming this, you will proceed to steps that involve additional wire checks and PCM updates. If the voltage is not at the expected level, the next steps will focus on diagnosing further wiring issues that may exist between the sensor and the PCM. In this stage, you need to conduct an open wire check specifically on the KSGND line. Begin by switching the vehicle into off or lock mode again. With your HDS tool, perform a short on the SCS line, which stands for Special Connector Short. It allows you to bypass normal fault detection during this testing phase. Next, disconnect the PCM connector C, which is a 51-pin connector critical for communication with engine components. Utilize a jumper wire to connect terminal A from the knock sensor 2P connector number 1 to terminal B, which is the body ground. With these connectors adjusted, you will need to check for continuity between the specified test points. Achieving continuity confirms that the KSGND wire is functioning correctly, providing a pathway for grounding, and if an issue is identified, repairs can be executed to restore functionality. The final troubleshooting step focuses on checking the knock line for continuity. Start once more with the vehicle in off or lock mode, just like in the previous steps. Utilize the same method, jumping the SCS line with your HDS tool to bypass continuous fault detection. Next, disconnect the PCM connector C again. This time, connect terminal A from the knock sensor 2P connector number 2 to terminal B, the body ground. Conduct another continuity test between these connected terminals. If the knock line exhibits continuity, this indicates the line is not broken and is in good working order. However, if there are issues, you will need to trace and repair the open in the knock wire that exists between the PCM and the knock sensor to restore proper sensor function and clear the DTC. After completing all necessary repairs, it's critical to verify that the issues associated with DTC P0328 have been properly addressed. Start by checking the DTC status using the HDS tool to confirm whether P0328 has cleared. It's also important to conduct a road test under conditions similar to those that previously triggered the DTC to ensure that the vehicle performs normally. During the drive, monitor the engine's response to ensure that there are no lingering performance issues. An effective road test will help validate whether the knock sensor is functioning correctly, the engine runs optimally, and that any previous symptoms have been resolved. Completing these steps ensures the driver has a safe and reliable vehicle that meets performance expectations. Preventive maintenance plays an essential role in avoiding future occurrences of DTC P0328. One proactive measure is to regularly inspect wiring connections related to the knock sensor. This can help identify wear and tear before it becomes a significant issue. Following manufacturer recommendations, It is also crucial to keep the PCM software updated to the latest version to ensure optimal performance and compatibility with the engine systems. Additionally, continuously monitoring engine performance can help catch any anomalies early and facilitate prompt corrective action. Adopting a preventive approach not only increases the longevity of component life, but it can also enhance overall vehicle efficiency and reliability. In conclusion, understanding DTC P0328 and the function of the knock sensor is vital for maintaining optimal vehicle performance. Following a thorough troubleshooting approach will help pinpoint the exact issue, whether it lies within the sensor itself, the wiring, or the PCM. It is essential to conduct systematic voltage checks to track down faults effectively. After repairs are completed, verify vehicle performance to ensure that all issues have been resolved. Lastly, regular preventive checks can foster early detection of potential problems, leading to cost-effective maintenance and a well-functioning vehicle. By adhering to these guidelines, vehicle owners can enhance engine longevity while ensuring a smoother driving experience. Please like and subscribe to the channel. See you next time.